Welcome, my dear students. It's nice to meet you. Today, we'll talk about the organic. Good, not any part. It's aromatic. It's phenol. We must learn each part about phenol. It's easy. And let's see. Phenols. To know this word, you must know that they are hydroxyl aromatic compounds where one or more OH groups are directly to what? Attached to the carbon atoms of the benzyl ring by removal of one or more hydrogen atoms. To see that, look at this. You have a phenol and you have a benzyl ring that bonded to OH. So we can say other name, carbolic acid. It's a good this name. Carbolic acid, this has OH only. If you have bonded by 2H by benzyl ring, you have catechol. Or yes, pyrogalol, it has OOOH. Yes, 3 are bonded to benzyl ring. In the same times, phenol here must be looked as you see. Carbolic acid can be written as C6H5OH. This replacement by benzene. Now, you have uses of phenol. I like these uses. Do you know why? Because it is used in very astringent materials of the many industries product. We have an example. Tell me what this example now. Polymers, dyes. You know that this not only the significance of the salicylic acid derivatives of aspirin. You know aspirin and bicric acid. We have different uses of phenol. Now, preparation of phenol can be prepared from different one as fractional distillation of coal tar. I think we used it before. This not only from halogenated aromatic compounds, all of them, they are used by hydrolysis of chloropenzene with what? With the sodium hydroxide. Not in any condition, must be at high temperature, which equal 300 degrees Celsius, and the high pressure also 300 atmosphere. This is the condition. My lover, you have a ring Cl and benzyl ring as you see, plus NaOH in the presence of the condition. What do you have now? I have phenol, yeah, benzyl ring bonded with OH, one OH. It's a good phenol. Carbolic acid, don't forget this word. Not all. You have also some of the physical properties. Catch this. You have the first one. It's a solid, corrosive. You know, it's a very corrosive substance. To what? To the skin. Oh, it's not good for this. But also, it has characteristics. Smell. Smell, yes, we know. At the same time, the melting point here is 43 degrees Celsius. It's a good one. But you have also a springly soluble in the water, and it's completely miscible with water, but not any condition. You have here a fixed temperature, which is equal 65 degrees Celsius. My lover, all of them, yes, but the chemical properties differ. For the first one, for the chemical properties, reaction is specific to H of the OH group. Yes, I know that. How can you catch this? This is not easy. As a beginning, it's know that the acidic property very important. It's back to what? Back to H. Yes, which is important. H ion. Look at this. The reaction start with give reason. What is the give reason here? Alcohols and phenols react with a strong metal. For example, Na and H2 gas is evolved. I ask, how can that? Yes, we know, because both are acid, don't forget. All of them has polarity of what? O bond H, which are bonded together, which give you by this equation C2H5OH. This is ethanol plus sodium. In this case, hydrogen will be evolved and form C2H5ONA. It's work as acid. We know that. Also, phenol plus Na. By the same method, what is the gas evolved here? Directly H2. And you have a benzyl ring C6H5ONA. I like this. Tell me what you have now. It's acid. Look for this. You have other question. These questions about phenols react with alkyls as NaOH and name carbolic acid while alcohol don't. Yes, I know. It's an easy question. We studied many times. Phenol has a polarity. The polarity increase in the case of the phenol due to the presence of what? Benzene ring. This not all, but you have a phenol increase the length of O bond H and it's what? Weakness, which facilitate the separation of hydrogen ion. So its acid react with base. Good example. But you have also equation. Benzyl ring OH as a phenol as you see plus NaOH. Directly the water must be out in the same time. C6H5 benzyl ring bonded to O bonded to Na. Good and easy. Now comparison between alcohol and phenol. This comparison to differentiate between the two important points. Reaction with, yes, R bond OH alcohol. For the last one, C6H5OH, it's phenol. Now, the first one for comparison, Na. Na, yes, Na. Na will react or not react with alcohol, should react and give hydrogen. With phenol, the reaction stay and give also hydrogen. But look at this. If you have NaOH, this it means alkaline. Yes, it's basic. For this case, you have no reaction with alcohol. Do you think this is reaction with phenol? Sure, the reaction will be benzyl ring ONA and water evolved. This it means you work through acid, carbolic acid, phenol. Now, reaction is specific to OH group. Yes, I know. OH group here, you must look for the first reason. The first one tell you phenols don't react with halogen acids. Yes, we know, it's easy. This is due to the strong binding of the oxygen of OH group. Very strong bond. This bond of the phenol to the benzyl ring. Now, you have the bond shorter. Yes, it's shorter, but stronger. So, it's impossible to eliminate OH group. So, stay as it is. Good and easy. Look, adding HCl acid to the alcohol and phenol, I think it's easy to know the answer. You have here a table, this table to differentiate between alcohol and the phenol. Now, add HCl. HCl with alcohol, yes, react or not react? React and give RCl and water stay evolved. But HCl is acid, phenol is acid. Acid react with acid? Sure not. No reaction. Don't react because you work through two acids. Easy and wonderful. Reaction is specific to the benzyl ring. We hear a special reaction. You have nitration. Nitration? Yes, nitration of phenol. When you say this word, I must remember HNO3. Phenol react with concentrated HNO3 acid in the presence of concentrated sulfuric acid. Now, I need nitration. So I must react with HNO3 to form what? 2, 4, 6 trinitrophenol. Oh, explosive material which is known commercially as bicric acid. Yes, I need to obtain bicric acid. I can do by this. When you put 2 milli of ethanol and 2 milli of the water in the test tube and the test pH in the universal indicator, I want to see the effect. This affection, it needs a special group. This group back to benzyl ring. Now, when it added, react start. So use a strength rod to put it in the drop of the solution to test the pH. pH here tell me what it is. As a beginning, you have here normal, no changing. So you have a normal? Yeah. pH equal what? It's 7. So neutral solution. It's good. But the reaction for the ring, it's acidic one. Now, observation for the comparison show the difference in pH. You have here a sodium hydroxide, phenol with sodium hydroxide. We know it well. This reaction is strongly one. When you put a spatula of the phenol in this tube and add about 1 milli of this sodium hydroxide, and I try to add some of the phenol. This is sodium hydroxide, add it to phenol, and I wait. There is reaction? Sure, I think because you have a reaction between acid and base. All of them, they are in what? OH, but I need benzyl ring. Now, observation. Phenol react with hydroxyl group. There is no color. Fly to this. Benzyl ring, OH. Here, 3HNO3, because I want to differentiate between OH for the sodium hydroxide and nitric acid in the presence of sulfuric acid here. Now, you have ring of the benzene with N2O, NO2, NO2. This it means you have 3 nitro. It's a bicric. Why we add sulfuric acid? I'll tell you, to prevent reversible reaction. Try nitrophenol 2,4,6 bicric acid. Important one. Also, we have it's used in manufactures of explosive materials, treatment of the burns, the importance of what? Bicric acid. Now, if you have and given to this can the yellow color, which is difficult to be removed, yes, I know, and it what remains for several days until the skin is colored. So it's back to what we know, bicric acid. Reaction of the phenol with formaldehyde. Oh, formaldehyde, I know it. HCO, it's formaldehyde. You have H, C, and HO. Catch this. Phenol react with formaldehyde in acidic or alkaline medium. Both of them, no difference between them. Why? To form copy. Yes, copy of what? Copolymers. And then what? Copolymers and polymerization process take place, I know, or condensation to form bakelite polymer. Bakelite, yes, I know. This is back. The reaction is polymerization. By what? By condensation. Now, in the first, HCHO, I know it, formaldehyde, react with 2 molecules of phenols, where the water molecule is produced to form copolymers. In the same time, you have phenol, C double bond O, C bond H, C bond H, yes, formaldehyde, give phenol, losing water. 2 phenols, yes, I know. Now, catch this. Oh, 2 benzyl ring are attached together, CH2 to bond between them. Now, second step, network polymerize is formed in which H2 phenols molecules here are linked. By what? By CH2. It's our group, you remember? Which bonded by C. Now, bridge 2 for backlight. This is a backlight polymeride. Now, this polymer help you to study this shape. 1, 2, 3, ring of the benzene, joined by CH2. Which important? OH for H1. You have a backlight. It's a good one. My lover, look, backlight has a dark brown color. You must know. Dark brown? Yes, dark brown. It has many uses, and this type of them setting across linking plastic, which is heat resistant. Not any one of plastic, no. Loading away of the heat resistant. Now used in electric instrument also. And the ash for this, ash trays. Yeah, very important. Detection of phenol. On adding few drops of FeCl3, it means iron-3 chloride solution, to phenol, what do you have now? A violet color is produced. It's very important to know this violet, it means the main detection of phenol. Good and wonderful. We have now give reasons. It's important to questions. When I say the fear of the vital force theory to explain the formation of the organic compound, do you think what the reason for that? Directly we can say because Weller prepared urea. You know the urea, which is the organic compound, were prepared in the lab. Also, we have by heating an aqueous solution of two inorganic compounds that are ammonium chloride. It's easy. What about the silver? And silver cyanide also is used here. This can be as an equation NH4Cl plus AgCNO by heating. You know that? Sure. What about silver happened here? Exchange AgCl. It's produced the silver chloride. Not all. We have ammonium cyanide, NH4CNO. It's good to catch this, but not all. The other four ammonium cyanide, NH4CNO, with more of the heating. Directly, we arrived to urea. It's a good organic compound, C double bond O, important, good functional group. And the two sides by amine group, NH2 for both NH2 and H2. All of them, you have a urea. Now, what's about to get another question for give reason? Alkane and cycloalkane are saturated compound. It's a good question. Saturated. Yes, we have an answer, my dear students, because all bonds between carbon atoms are single covalent bond. It's good to say that. Also, we can say alkene and alkyne are unsaturated compound. Yes, there is big difference. Here we haven't a single bond. We have what? The presence of the double bond in alkene and triple. Well, a triple bond in alkyne between carbon atoms. It's good to say that. You remember sigma bond and pi bond. Very important to say that. For the other question, alkenes have general formula CnH2n plus 2. You remember that? Yes, very important. Now, what about the nomenclature of this alkane? We know the names. Can you write this name? Sure. The first, you have CH3, CH, CH2, CH2, CH3, all by alkyl CH3. Tell me, what is the name? 2. Methyl bentene. No, it's a pentane. Why we say that? Because you have single bond. The other one, oh, it's long one. It's not important. CH3, CH, CH2, CH3, CH2, CH3. What does this mean? How many carbon we have? We have about 1, 2, 3, 4. It's 4. Yes, the long share here, it means 4. What is the name now? The name will be 3-methyl pentane. This long chain, as you see, you have here 6 carbon atoms and alkyl group, yes, in the carbon number 3. Directly, we say the other one. What about this? It's longest chain, 1, 2, 3, 4. I know it. 2 alkyl group for each side. So, the answer, 3-methyl hexane. Why we say hexa? Because I have 6 carbon. So, group of alkyl joined by the carbon number 3. Good word and good name. This, not all. Nomenclature is very important. Look at this. We have a long chain. How many carbon? We have many, many, many. I want to research for the longest one. Now, give me the name. Easy. Say it as 2, 3. Oh, 2, 3? Yes, because alkyl group joined by carbon 2 and the carbon 3. Benta, we say pentane, dimethyl, good, dimethyl pentane, because we have 5 carbon. The other name for this, it's longest one. Yes, I know, but take care for the carbon number 3. It has 2 methyl group. Now, what is the name? Directly, we can say 3, 3. Why we say that? Because both are found where? In the carbon number 3. Dimethyl pentane. Good and wonderful name. My lover, this the different one because we have Br. It's not important. By the same name, 3 carbons. What is the name? Yes, 2. 2 bromo because bromine here in carbon number 2. Propan, 3 carbon, and it means single bond. The difference when I say CH3, CCl. Yes, I know. In the carbon number what? You say 2, 2. Why? Back to the carbon number 2. Dichloro, because I have 2 Cl. Dichloroputane. Good and easy. Take care. You must get full mark for this part. It's important and about 3 questions, partly in the exam. For the other one, when I say CH3, CH3 connected by methyl and Br. Now, can you catch the answer? Don't ask. Directly say what you have. You have this. 2 bromo. Yes, carbon number 2. 3 methyl. Yes, because methyl in carbon number 3. But it means what? 4. Good word. And we have a single. 2 bromo, 3 methyl butane. Now, we have the longest one. Oh, it's not longest enough. Now, catch it? Easy. ClBr. What this mean? It means 2 bromo, 5 chloro, hexane. Good name. 2 back to the carbon 2 for CF bromo and 5 back to Cl. So 2 bromo, 5 chloro, hexane. Good words. The names is very important. What about this? It's the longest one. Catch this word. It's easy. You have a methyl group and ethyl group for the other side. So nomenclature will be as you see. 3 ethyl, 2 methyl, octa. Octa, it means what? 8. Octane. It's good to say that. Now, look at this. Different groups of methyl are found for this section. 3 H3, CH2, 2, 1, 2, 3, 4. You have 4 methyl. What is the name? The name directly 3, 3. Trimethyl. 3, 3. And we have a 5. Yes, why we say that? Because 5 here, it has a group of methyl. So, 3, 3, 5. Trimethyl heptane. Hepta. Hepta, it means what? It's a 7 here. Good, my lover. What about this shape? CH3, CH2, CH2 bonded by 3, CH3, CH bonded by CH3, CH2, CH2. Oh, what this? It's long. Yes, okay, but it's easy. Try to find the longest chain, the longest carbon. As you see, good word, just one group of methyl. So, in carbon 4, you can say 4-methyl. Because in the carbon number 4, heptane. I know it, it's hepta, because we have 7 carbon atoms. Good, my lover. This not all. What about methane, CH4, CH4? Can you prepare it? Can you know it? Sure. 1 carbon only with 4 hydrogen. What about to prepare methane? Can you prepare methane in the lab? I think, yeah, important to say. But how? Look at this. When I say you find dry distillation for anhydrous sodium acetate, not only with soda lime, giving the methane. This one, yes, can be. This in where we have a special device. You have here soda lime. Soda lime, it's a mixture of what? Caustic soda, NaOH, and quick lime, CaO. Now, what you have, look at this. This is a heating. Yeah, we have a heat. When it start to heat, it start to move anhydrous sodium acetate and soda lime. The gas start to be formed, as you see, and the water as a bubbles. This is methane gas. Great. It's completely great to know that. What this also, the equation, don't forget any preparation should be equation. You have sodium acetate, CH3COONe, plus what? Yes, caustic soda, NaOH. Directly, we have an answer. Take care, you have a heating and the soda lime. My soda lime, it means what? It's lime. Good, CaO. I need it. The answer directly must be methane, CH4 plus Na2CO3. This is not important one. The most famous one here is good gas of swamp, methane. Now, you have a methane now. It's easy? Sure, it's easy. My dear students, we arrived to the end. You understand the lesson? I think, yeah, it's very easy lesson. All time concentrate for the lessons to obtain a full mark and high marks. See you soon. Thank you and goodbye.